Welcome to my channel, Yuvraj Kushwa, and today we are going to discuss some discrete mathematical topics. So our today's topic is introduction to Boolean functions. So Boolean functions, what are Boolean functions? Boolean functions are the fundamental building blocks of digital system. They are basically they describe the relationship between the binary digits of input and also shows the binary relationship between the input and output. Now we will move further to the next slide. Boolean algebra and operations. There are basically three operators which are AND, OR and NOT. AND, which now we will discuss about the first operator. The first operator is, you can see on the slide, AND operator. AND operator function is that if one output, if the input is 1, binary 1, then the output will be only 1. If there is 0 in that input, so it will be 0. So the binary input must be only 1. Now we will discuss the second operator, which is OR. The OR operator performs the basic function that is if it consists one binary bit, it will display 1, and if it will display 1 or 0, then it is always 1. So now the next operator is NOT operator. NOT operator is basically inverts the binary operations. Like if we transfer one bit, which is one signal, it will convert it into 0, and if we transfer 0, it will convert it into 1. Now we will move to the next slide. The third topic is representation of Boolean functions. We can represent Boolean functions by various methods. We have three methods to discuss about. The first method is truth table, the second method is Boolean expression, and the third method is corner maps. Truth tables basically are in truth table we make two blocks, one for true and one for false, and the third and we make another block which is for result, which shows about the basically representation. And the Boolean expression we have discussed in the previous slide, which are AND or NOT. We can diagrammatically represent them also. Now the third is Kornov maps, graphical method. Kornov map is very important method for representing these Boolean representations, because it gives an accurate view of that Boolean functions. Now we will move to the next slide, which is minimization techniques. What are minimization techniques? Minimization techniques are nothing. These are applying laws and theorems to simplify Boolean expression. Basically, we like Boolean Kornov maps, Quinn, Mac, Closey, and we apply some basic laws, simple laws, to simplify our big equations to small equation. Now we will move to the next slide. Kornov maps and Quinn Maxwell method. We will discuss the minimization techniques in detail. Kornov maps are the graphical mathematical representation of those Boolean algebras. Now the Cuny Mac Closey method is tabular method. Tabular method means we represent them in a table. So the operators and the results are very clear to us. Now the compressions. Kornov maps are intuitive but limited to 4 to 6 variables. Kornov maps, if we describe Kornov maps, they are only limited to 4 to 6 variables. But in the second method, which is Queenie Mac Closey, we can handle large functions also. Now we will move to the next slide. This is synthesis combination of circuit. Synthesis combination of circuit. We have the different steps. The steps to follow in synthesis combination circuits are: first step, to obtain Boolean expression for the design function. We will obtain the Boolean expression first. Now second step is to simplify the expression using minimization techniques. We discussed minimization techniques in previous slides. So in second step we will minimize the Boolean functions. In the third step, implement the simplified expression using logic gates. Now we will represent those minimized functions in form of basically logic gates. Now applications of these synthesis combination circuits are: combinational circuits are used in wide range of digital systems, from arithmetic units to control logic. We see our devices nowadays, and modern technology, we see devices like computer, laptop, mobiles. We have these techniques in these devices also. Advantages. So combination circuits are very fast, as we know that the technology is growing nowadays and the combination circuit give a boost to these technological advancement. Now now the next slide is we are going to discuss the synthesis of sequential circuit. We have basically three synthesis techniques. The first is state machine, second is feedback loops, and third is design challenges. State machine is sequential circuits use flip flops to store previous state and transition to new states based on the current inputs. Basically, we all know about the flip flops. Flip flops are in this synthesis of sequential circuit. Flip flop store the previous state and convert that state into new state based on the current inputs. Now we will move on the second state, which is feedback loops. The output of a sequential circuit depends not only on the current input but also on the previous state. Basically, the input which we are providing to the circuit depends on the output, and the output also depends on the input. Now the design challenges. Sequential circuits are more complex than combinational circuits, requiring careful consideration of timing and feedback. Sequential circuits are more complex because it requires much more hard work than combinational circuits in making them. So requiring careful consideration and timing. It also consumes our time, and it is very complex to build. Now we will move to the next slide. Application and practical consideration. Digital computers, Boolean functions and logic. As we all know that we have come to the end of this video. Now today we are using our PCs, laptops, phones. These are the practical examples of these Boolean algebra. You can see here digital computers. We all use computers nowadays, so these are practical life examples of Boolean algebra functions. Thank you, and if you like the video, please subscribe it and like it and do comment on the channel and share the video.